So as I was saying that the type of the hydrogen, in fact, the first one, which is very uh, dominant, I would say, in the today's worldwide scenario when it comes to the usage and the production, almost 98% is gray hydrogen. And why do we call gray is because it is, when it is produced, it comes with a lot of carbon emissions. Now, eventually, in today's time, this is the time when everybody and the whole industry and the whole world is focusing on the reduction of the emissions and the carbons. So, while gray hydrogen today has a lot of usage, but slowly and gradually, the governments and the policies and the industry and the leaders, the climate change leaders, they are trying to replace the gray hydrogen with the green hydrogen, which would not have any kind of the emissions. So as the name says, green hydrogen is something which is nearby carbon free, I would say, and a little bit of the residual carbon that is associated with the green hydrogen is because it is not 100% green hydrogen, because when we produce the green hydrogen using, for example, a pump or a motor or a compressor, I would say, now those equipments while manufacturing had produced some kind of the carbon emissions. So that is why the green hydrogen is not 100%, but yes, we can consider it to be 99.99% green. In between green, there is blue hydrogen, which is a kind of a carbon capture process. That means when the gray hydrogen is produced, the clean hydrogen is taken out for the process, and the carbon emitted through the process is captured, and which is then converted into the useful carbon products. So that is called blue carbon. Then we have different kind of the 2-3 more which are very small in nature and which are not very relevant, but just for the information sake, I would name them, which is turquoise hydrogen, pink or purple, and yellow. But yes, as a learner, I would say, or as a hydrogen guy, one should remember that there are three main types of the hydrogen, which is gray, blue, and green. And I explained there is a distinguished kind of the difference between these three hydrogen cases. Now, let us see that what India is doing when it comes to the green hydrogen. Now, India has in fact decided a target that by 2030, and the mission which India has decided, that is called National Green Hydrogen Mission, NGHM, and this comes under the Ministry of the MNRE, which is the Ministry of the New and Renewable Energies. And India has decided a target of 5 million metric tons of the production of the green hydrogen. This is a massive one, and I believe that this is the second largest mission in the world today. If we compare all the the countries which are working on the hydrogen, India's green hydrogen mission comes at the second number. There are many other countries, more than I would say 20 major economies, who are working on the green hydrogen. And India today stands at number 2 when it comes to the target size or the kind of the investments that are being rushed in, and the kind of the developments and shaping the entire, I would say, the industry sector. Now, this 5 million metric tons of the production of green hydrogen, if I have to break it, this is what it would need. It would need 125 gigawatt of the electrolyzers capacity that needs to be set up in India. This also, because the hydrogen that we are going to produce has to be the green hydrogen. That means we cannot use the currently available grid power from India or from the Indian grids, because the India grid still operates or has almost a 70% of the coal-based power. Hardly 30%, 31% maybe. Today we have from all the renewable sources, and primarily these are solar, wind, hydro, and nuclear power. So, of course, again, in case if we use the power from the grid, that becomes not a green hydrogen, but again a gray hydrogen, because it already has a trail of the carbon emission behind it. So, to set up this kind of the capacity, we need to set up additional renewable energy, which could be almost, I would say, about 150 gigawatt that we still need to add into the grid simply for the hydrogen production. Besides our current target of 500 gigawatt, that as the under the renewable energy mission that we have to produce. Oh, so 500 that, out of which we have almost achieved 250 gigawatt. So that remains almost 250 gigawatt plus 150 plus gigawatt to be done. So again, that becomes itself a massive target, I would say. And these both missions support each other. Similarly, we have a huge water requirement that we will need, because production of the green hydrogen is a process that generally comprises of feeding the pure quality of the water into a specific, I would say, kind of the equipment that is called electrolyzer. And the purpose of this electrolyzer is to break H2O. That means we have the two portion or atoms of the hydrogen here and the oxygen. So what does the electrolyzer does is that it will separate the hydrogen and the oxygen. So we collect the hydrogen from the electrolyzer and we collect the oxygen from the electrolyzer, and they both are used in the industry in the process. We all know that pure oxygen is sold as a kind of the commodity, and similarly green hydrogen or the hydrogen that is coming out of the electrolyzer, that is also being used in the industry. So as I said that besides the main equipment, which is electrolyzer, then we have the renewable energy that is required. Then we need the balance of the plant. By balance of the plant, I mean to say that you need to have the huge sizes of the rectifiers. You need to have the gas separators. You need to have the system which are gas purifications, because you need to separate out the gases, the hydrogen and the oxygen. Then you need to purify them. Then we have huge electrical systems associated, civil and the structural works, mechanical utilities, instrumentation, safety, manpower. So it's a huge kind of the mission, National Green Hydrogen Mission, which is 5 million metric tons per annum. That is something which is massive, and that is going to generate, I would say, approximately 1 million jobs in the next 4 to 5 years. That is 10 lakh jobs across. And this is something which I'm speaking direct jobs. There are so many indirect jobs as well, which will be associated with this mission. Now, this is something that people may not be able to note right now, but they are very, very relevant and they are very important. These are basic 10 set of formulas that we generally, the hydrogen, I would say, people or the experts would use while designing any kind of the plant. How do you see, for example, if there is a specific requirement which says that, oh, you need to set up, to produce, say, 10 kilograms of the hydrogen. So how much water do I need? So of course, you go to the project specific, you go to the details, you go to the calculators, and you start working. But as a thumb rule, you must remember that 1 kilogram of hydrogen needs 9 kilogram of the water, or 9 liter of the water, I would say. So that's the thumb rule that we generally use. For example, if you are trying to work out the overall capacity of the project or a plant, that is the thumb rule. Similarly, how do you calculate the levelized cost of the oxygen? That means, for example, if today we start with a hydrogen plant, which is going to work for the next 25 years. So over these 25 years, what is going to be the levelized cost of the hydrogen? That every year, whether I am producing the hydrogen at a cost of 300 rupees or 3000 rupees. So that is the formula, that LCOH, which is levelized cost of the hydrogen, which is calculated and computed in a particular manner. Now, similarly, producing green hydrogen means that we are directly replacing the carbon dioxide. We are directly reducing the emission associated with the CO2. So how much, for example, 1 kg of the hydrogen will replace, for example, if we are using today a hydrogen car or a hydrogen truck, which uses 1 kg of the hydrogen per day. So that means 1 kg of hydrogen, when it is being used by a diesel truck, which earlier was using diesel, today it uses hydrogen. So it is going to save almost 8.8 kg of CO2 every day. So these are generally, I would say, the formulas that are generally used in the calculations, in the computations. Then there is a broad breakup of, for example, for a mid size of the hydrogen project, which is almost 400 crores, where does the money go? in a project, when we are setting up, whether it is a renewable energy project or a wind project or a nuclear power project, then there are different heads, and we must know that how much we have to budget for each and every section. So this is how the money would be split. Electrolyzer system being the heart of the complete project would amass a total almost 40% of the project cost in terms of the capex. That means if we are spending 400 crore rupees on a particular project, hydrogen project, almost 160 crores would go to the electrolyzer purchase and setup only. Besides this, we need to have the renewable power. So, of course, there would be a cost to it, which could be about 100 to 120 crore rupees. Electrical, then water treatment, then storage and handling, then civil and structures, instrumentation, engineering design, commissioning and testing. So, this is kind of the breakup, I would say, for a complete project here. Now, this is how, in a very, very simple kind of the language, I have tried to explain that how green hydrogen is produced. We first of all have the renewable energy generation, which could be either this wind or the solar power. Of course, I haven't considered here the nuclear or the hydro, because those are not very, very, I would say, relevant for the for a lot of geographical locations. This power is being fed into the electricity, this to the electrolyzer, which is, as I shared with you, that the main equipment which separates out the water into hydrogen and oxygen. So this electrolyzer will convert the water particles or the water inlet to these two gases, from where the gases are collected and they are taken for the distribution and storage in case if we do not have the on-site kind of the consumption. And then from there, it is being sent to different kind of the applications. For example, to a steel plant or to a fertilizer plant or to a glass factory wherein they need the high temperature. Cement kiln, in fact, you need a temperature of 1400 degrees, and which you are generating by using right now the fossil fuels, which are emitting a lot of carbons. It could be sent for the maritime industry, for the shipping industry, to the local transportation system, etc., etc. There are so many uses of the hydrogen today in the world cases that it's practically, I would say, very difficult to write each and everything here. Now, as I said, that hydrogen, in fact, one thing which we must remember and keep in mind is that hydrogen is not electricity. It is a fuel. It is a kind of a fuel. It consumes the electricity, and then we produce this kind of the fuel. For example, in a fossil fuel like petroleum products, we have the crude oil, which is converted into so many products, whether it is petrol or diesel or gasoline or other kind of the derivatives, polyvinyl derivatives. Similarly, hydrogen, once produced, will have so many kind of the further derivatives, and this hydrogen can be converted into green ammonia. This can be converted into green methanol. It can be converted to synthetic fuels. It can be used directly as a fuel for the green steel. That means not using the fossil fuel heat, but using the green hydrogen. That means you are avoiding all the emissions which are associated with the steel, and those emissions are very, very heavy. In fact, the total emissions of India today, if we look at the sector wise, about 30 to 35% comes from 4-5 sectors only, which is chemicals, refineries, steel, then we have fertilizers, and then we have glass. These are some of the heavy industries which are producing the maximum emission and the more of the carbon. So in case if in the next couple of years, 4, 5, 10 years, if we are able to replace hydrogen, these kind of the fossil fuels with hydrogen, India as a country would be able to reduce almost 40% of their global emissions, and which is a SDG goal for us, for India as well. Some of the projects, some of the big names and how they are spending the money, you can see here. Reliance, in fact, has a very, very huge, ambitious plan wherein they are going to invest almost 75,000 crore rupees into the green hydrogen mega complex which they are setting. Adani has also committed almost $50 billion. Acme Group has invested close to, I would say, in different kind of the projects, this is a 52,000 crore I have mentioned, but yes, they have other projects as well. Acme Group, then SR. SR is also building a green molecule complex at Hazira with an investment of almost $4.5 billion. These figures are still, I would say, old because every day we see new reports coming in wherein the project numbers are being revised or being enhanced rather. Because they want to add this also, they want to add that also. So there are similarly other ONGC, IOCL, BPCL, the complete, I would say, the oil and gas sector, the fertilizer sector, IFCO spending a lot of money, Deepak Fertilizers planning to come very heavily in the green hydrogen. So these are some of the numbers that I have been able to capture here in one single slide. Now, let us come to how AI, in fact, has been kind of, shaping the hydrogen value chain or the hydrogen economy. In fact, the AI has been playing a very, very important role, and it is right from the production phase till I would say the distribution and the end use case as well. Now, for example, in the production phase, AI tools are helping electrolyzers to optimize their working because electrolyzers some electrolyzers work at high temperatures, some work at the ambient temperature, some work at the higher pressure, some work at the normal ambient pressure, different voltage scenarios. So AI definitely helps us to optimize the performance of the electrolyzer, which is a very major component when it comes to the OPEX, I would say the operational cost. Electrolyzers consumes almost 60% of the total operational cost. That means, for example, if we are spending 100 rupees to produce 1 kilogram of hydrogen, the electricity cost would itself be almost 60 rupees. So the optimization of the electrolyzer performance is very important. Then secondly, then the AI tools helps us to in the load dynamic management, because we know that the RE, in fact, is not a very stable kind of the power. It will have ups and downs. There are so many variations in the power output available. The predictive tools helps us to understand the behavior of the electrolyzers and how we have to manage with our outputs and the volumes. Similarly, digital twins of the electrolyzers, different sensors are kind of associated with the electrolyzers, which normally would replicate the performance of the electrolyzers onto the screen for a performance management guy who would keep on adjusting the values in the system for the best of the working. Similarly, in the storage and distribution, we smart monitor the storage, how the storage is being done, and how we can enhance the safety and the storage. Similarly, in the pipeline, because the hydrogen or the ammonias, they are generally sent through the pipelines. So it is very essential to monitor the flow rate as well as the pressure and the temperature inside the pipelines, and the AI tools normally help. I have a separate list of all the software as well. But yes, that's a lengthy topic, so I did not include it here. But yes, again, AI in the logistics, we know that how the AI predictive maintenance tools can help us at the plant design stage itself. AI, digital twins, and there are many other software which help us to optimize the complete plant designing. For example, the amount that I just took, that is for a very small kind of the hydrogen project. Hydrogen projects run into billions of dollars. So even if we are talking about, say, 500 crore rupees, and if by using all this, if we are able to reduce, the operational cost hardly by 10%, and the capex, the capital cost hardly by 10%, and the operational cost by 10%. So that means that is a saving of 50 crore rupees for the capex, for the OPEX, capex only, and another perhaps in case if the OPEX is 250 crore rupees, that would be a saving of 25 crore rupees. So AI, of course, is playing a very important and a very, I would say, huge role in the plant designing, in the plant manufacturing, and in the plant operations as well, to make the hydrogen economy very viable and cost economical for all of us. With this, I would just close my presentation, because there are other people as well who have their valuable insights on the other aspects of the AI. Thank you, Vivek. Thank you so much, guys.